Imagine a world where there are none of your favorite applications and none of the operating systems that are actually powering them. Crazy, right? Now let's dive into these softwares and operating systems that power them and build them, starting with the very basics, which is C. Now, before we begin with C programming, there are some things we should know about. First of all, we would figure out how software is divided. Softwares are actually divided into three parts, that is, application software, system software, and utility software. Now, starting with the system software. So, system software includes languages that we know of, such as C, C programming languages, C Sharp, and many more programming languages like Python, JavaScript, Java, that we all know and love. Now, these are considered system softwares, and also the other thing that is included in the system softwares is translators. Now, you see, computers don't really understand English like we both do, but the only thing computers do understand is low level languages like binary code. So, translators are kind of like helpful to us. They translate programming code that is written in English by us into binary code that computers can understand. So these are also considered system softwares. Now translators are also of different types. We will understand it right now. See, there are basically three types of translators. There's one compiler, there's an interpreter, and there's an assembler. So compiler is pretty simple. It basically sums up the whole code and it finds out all the errors that are present in the whole code. Now see, interpreter is pretty different. What it does is, see, like we have 10 lines of code. So interpreter would go from one by one, like one step at a time, one code of line at a time. It would go out for the first line. If it finds any error, it would stop there, does not execute the rest of the code, and provide us the error at the first line. Now see, the difference between compiler and interpreter is pretty simple too. Compiler, as it interprets the whole code, like compiles the whole code thoroughly. So there's 30 lines of code and there are 3 errors overall. It would give us the 3 errors at once. But interpreter would stop at the first error that occurs, and would not give us the rest. So yeah, that is about it. And see, there are assemblers. Assemblers are pretty simple too. They just deal with the middle level languages. Now moving on to types of application softwares. There are many types of application softwares, such as desktop applications, web applications, mobile applications, AR, VR, and MR applications. Now AR and VR are pretty much known to us. VR is virtual reality, AR is augmented reality, and MR, which is quite new for some of the people, it is mixed reality. One of the examples of mixed reality which could be seen around us is Microsoft HoloLens. It is a product that's provided by Microsoft. Now moving on to C programming language, which is pretty simple to be honest. I'll teach you guys some for loops, some if else statements, some switch cases, and using all of it will build an amazing candy game. Yeah, sounds interesting, right? So let's just dive into the C programming candy game. Now moving on, we'll take the input from the user. So basically we're taking an integer, so we'll take %t and in percent to the place where it should be stored, which is b in this case. And let's see if it takes the input. Yep, it's taking the input. Just checking and moving on. So here comes the conditional statement. Let's say if a and the input that we take in b are same, right? We'll print the values are same, right? And now basically moving on, if a and b are same, it will print the values are same, and then we'll use something more interesting called the else statement. If they are not same, then what we'll do is we'll print the statement they are not same, right? Let's run it one time and see how it goes. I'm putting 4, they are not same. We'll run it once again. I'll input 8 and it says the values are same. Pretty easy, right? Yep. So these are called conditional statements. Now I think I've pretty much given you the base content for the candy game. So let's move on to candy. Since guys I don't have Turbo C, I'll be doing the whole candy game code. I'll just showcase it to you since I don't have Turbo C. So because Conio doesn't work and Conio's commands like text color doesn't work in it, so we'll just understand through this code. So basically we need a candy, and in this code we represent the candy by 0, and this is the thing that run besides it is the basket. So we'll start with a void main. We'll declare the x and y values of candy and box to begin with it, and we will take score as 0 at first, and there will be 3 lifelines provided by us to the user, and we'll take character ch for the keyboard hit value, which we'll use further. So basically when we start, we'll clear the screen first. We'll go to candy x and candy y, which we have declared here, 40 and 3. We'll make a candy there, which candy's color would be red. Then we'll go to 70 and 2. We'll choose text color as yellow and print our score over there. Then we'll go to 70 and 3. We'll go to yellow. We'll print as yellow color, and we'll choose the lifeline to print there. And it's also an integer. You will use %d. Then we'll go to box x and box y to print the box values. We'll print the box as green. We'll use hashtags to make the box like I shown above. This is how the box will look like. Yeah. And we need to remember, if the candy falls on this, we do not have to give any points. The point should only be given when the candy falls between these two areas. So yeah, now we'll move on. So basically here we're just printing the box, and we do need to remember, guys, that x's value has 80 pixels in Turbo C++, and y axis has 25 pixels. So that is why how we are using x and y here. And do also remember there is no values such as in x and y. In pixels there is no value 0 0. It goes outside the screen. The values start from actually 1 and 1, which is on the top corner of the screen, like right here. Okay, so we move on. We have taken this variable, so it's easier for us to print the boxes, and as we would iterate the box through the screen to left and right. So let's move on to the movement of the box. So basically if the user hits the keyboard, then only then the if statement will execute itself and start the switch case. So basically we'll see that which character has been used to start the keyboard, and we'll store it in a ch. Then if we can use small a, the user can use small a or big A to move the box towards left. See, these conditional statements are very important, because if the box moves towards the very left or the very right, it gets deformed, and it would move in very random ways which we cannot predict. So we need to keep in mind we use these conditional statements to make it confined in these areas, the areas of the screen. And we'll use D to move towards the right, so we'll increment the box towards the right side and move towards the right side, and it should always be greater than 1. So yeah, it doesn't move to outside the screen. Now if the user wants to exit in the middle of the game, it just presses X and it will exit 0. That means 0 means it's not a forceful exit, it's a normal exit. Now since the candy has to spawn from random ends of the screen, we need to use this, and this will also calculate the score. So basically if candy hits 24, which is a baseline for the box, so 24, see 22 is box's y, and if it hits 24, the score will get plus because it's hitting the end of, you remember this, this is how it looked like, the end of a box, these 4 hashtags. So yeah, that's that. If candy hits that 24th line, this is a 24, so y is 24 here. Candy, so yeah, y is 24. Whenever it hits 24, the score should plus itself, and there will be a sound. We are using sound here, and there's delay here. So sounds 500 over here is being measured in hertz, and the delay is measured in milliseconds. Yes, and no sound is important, or else it will, if you don't use no sound, the sound will go on forever. We need to use this. This is very important, guys. And in the else statement, if it doesn't hit the basket and it hits anywhere else, the lifeline would be taken from the user. There would be a different sound playing. See, remember, these are hertz, so they play different sounds at different frequencies. And see, this is how the candy spawns, right? So the candy Y would be at 1 always, starting from the top of the screen. Like we told, it starts from 1 and 1, so it's basically this corner, starting from this area, and it will fall at random values. So using a mathematical function called random, RAND, and would modulo it by 80, since so the value would not be greater than 80 and it would be confined to the screen itself, and we'll add 1 with it, since if it ever comes 0, so it will just add 1 to it and would not go outside the screen. And if lifeline gets 0, we'll clear the screen. We'll go to 35 and 13, which is pretty much the center of the screen, and we'll in blue color print game over. There would be sound effect, and the character would be taken and the code would be executed to just like end the code. It terminates the code in a normal way, exit 0, like we learned earlier. See, whenever we use exit 1, that means it's a forceful exit, and exit 0 is not a forceful exit. I'll just write it right here for future purposes if you guys want to use. Yes. And if the score equals 3, we'll just clear the screen. We'll go to 3530 like center, and we'll just colorly print. Cprintf is basically color printf, and we'll use text color blue, and we'll print U1 with the delay of 200 milliseconds, and then with the same way we'll just normally exit the code and terminate the code, and with the delay of 200 seconds it will just go to start again and get the character. This is how the code works. I can't actually run it on it because I have a Mac and I can't use Turbo C++ in it. So that's that, guys, and I'm Vedant Thakkar signing off right now, and we'll come up with more C++ videos and C videos in the future. Thank you, guys.